Hey, Jim Bergmann with measureQuick. Just wanted to take a few minutes today and catch up with Nate Adams. We have been going down a rabbit hole in a journey together for a little while on heat pumps. Nate is the one that persuaded me to put one into my house and turned me from an enemy of heat pumps to actually an advocate of them.
I'll tell you what, Jim, that meme that Brian Orr made of you sitting in your rocking chair looking all smug that says gasify everything back in 2017.
I still like my gas furnace, but only on these cold days. It's very cold here in Ohio today. It's somewhere around 10 degrees. So it's finally switched over to the more economical heat source that's much less comfortable. So
I basically busted your chops on heat pumps until Mike Platko and Tim Portman busted your chops too. And next thing you knew, you had a Bosch.
I'm on my second one now. New house, new Bosch unit. So it's been an interesting journey. I got a call this weekend from a colleague, and one of my employees went all in on electrification, and now he's getting these huge electrical bills, and he's freaking out. And can you talk to him? And I'm like, yeah, just give me the number. I'll give him a call. The guy was an engineer, pretty familiar with electrical and stuff like that. He had already had an Emporia view on his house. And I'm like, there's two things I'll tell you about electrification. It's going to cost you more money in the winter to run a heat pump. You're going to spend more money, but you're going to spend a lot less money in the summertime on cooling. So your bills are going to flip flop, especially with a Bosch unit. He had a Bosch unit too. And that thing runs all out in the wintertime. Condenser fans run full speed. The compressor's ramped way up. It's constantly maintaining the same head pressure, irregardless of outdoor temperature. So it can over ramp a little bit, but then its amp draw is the same like mine. It draws about 9 to 11 amps, whether it's on low fan speed or high fan speed, but my fan speed goes up and down, but my Bosch unit, because it's maintaining pretty consistent head pressure.
Although I wish they dialed down more.
If I could. Just a limitation of my air handler. I can only dial it down so far. But it was interesting at the end of the day, it came down to balance point. And his balance point was set too high. And he has his backup heat's electric heat. And I'm like, you should never shut that heat pump off until the Bosch unit, you can run it down 4 or 5 degrees.
Does it have a hard cutoff?
It does, has a hard cutoff. I looked it up on the manual.
Mine didn't hit it because we were below that 2 weeks ago. We got to -5 here, which is way below.
Yeah, I think -5 is where it cuts out. So it might have just been on that threshold. But he's up in the Minneapolis area. So they're at like -10 right now. And so this is where cold climate heat pumps become a little bit more valuable of a tool as you get into the
You have to in climate zone 6 if you're going to go full electrification. If you're running a hybrid, it's not a problem. You just let the furnace take over below whatever you're giving.
Running a hybrid, it's just a hybrid with the most expensive backup heat you could have. And there's two things they're doing. They're also not only were the balance point was set too high, but they were completely shutting off the heat pump and then running straight electric heat. And I'm like, no, don't do that. Just keep the heat pump running all the time and just temper the air with the electric heat.
Yeah.
And because you're always getting some heat out of the heat pump, even if it's 80 degrees.
Even if it's a 3-ton unit only putting out a ton, you're still running it better than a 1 COP. Basically, regardless. I mean, a 1 COP goes down to what, like -20 or -25 Fahrenheit?
I think we're going to see some interesting things when people are doing electrifications, and that is installation errors that are going to cause this equipment to run poorly, primarily poor evacuation and charge issues and airflow issues. Those are always giant issues, let alone duct leakage outside of the envelope, but the poor control configuration. And
commissioning makes or breaks these setups. It really does. I allow cold blow on my units, and that saves 1,000 to 2,000 kilowatt hours a year.
Yeah.
Just bump the temperature by a degree, the set point. Like you normally run at 70, run at 71. It'll drop the air temperature in the house by a degree, but because all the materials are warm, I haven't had anyone ask me to change it.
Yeah, but how often are you on cold flow?
Every 90 minutes.
In the shoulder season, you're never on it. Like I think my unit's been running probably an average of 16 to 17 hours a day in this current weather.
Defrosting?
Oh, it defrosts.
Cold blow happens during defrost. So
yeah, okay. I thought you were talking about there are heat pumps that have an indoor coil sensor that don't allow the blower to start until the indoor coil is up to 50 degrees.
Nope. Just in the defrost cycle is because, resistance costs 3 times as much as the heat pump, depending on whether you're running.
Yeah, I experienced it for the first time last weekend. I had an issue where my thermostat satisfied during a defrost cycle. So my wife was cooking or something, and so it didn't call for heat because it didn't have a call for heat, but it still had a call for defrost. So it's just an interesting.
Did it blow on her?
It blew on me. I was sitting in my chair and I just felt the cool
Okay.
air coming out of it. I was just surprised because I had to run down and look at my furnace to make sure my furnace was not working because normally it would kick the furnace on and I'd never even know it. The heat pump stops.
But the furnace gas is cheap enough.
But the key thing I think we're going to find is you mentioned commissioning, but like when we talk about commissioning, it's actually a big part of its control configuration. And a lot of people aren't taking the time. And these thermostats are very complex. I still think one of the most important things to do is find a thermostat that you like and stick with it. Yeah. Because
you know what mine, I hope you know what it is, right?
the Infinity Stat.
Infinity. Yeah. The carrier Infinity Stat.
Yeah. I found I'm trying the Bosch Stat right now. It's a little bit complex. It's got a lot of sub menus you got to go into through a certain code installer menus.
Yeah.
I was using Sensi 2 at my house, which I think Sensi's got it licked for probably this most simple thermostat to install that doesn't do latching, that also is just super simple to configure. It was the simplest configuration of anything I've ever done.
One of these days, I'm going to drag you over to a communicating system, and then you're truly going to come to the dark side, Jim.
Yeah.
There's a bunch of things you don't even know about.
I've been there. I had a fully communicating ream unit with a full modulation gas furnace and a communicating outdoor air conditioner. The thing
How long
I loved,
ago, though?
it was a while ago, and I loved all the data and all the things I could get off of it. But what I hated was a thermostat went out on it. It was like $1,000 thermostat. So
yeah, that happens.
Yeah, but it's a lot of money for a thermostat that doesn't really provide. It's your primary temperature control. I get it, but it doesn't provide the comfort in the house like the system does. So you can get decent comfort with non-communicating equipment.
But man, it's a step up. You'll hate to hear me say this, but I'm going to pull the Bosch off this house. And
That's because your house is way too big for the house.
Actually, it's not for heating because this house is so crappy on the shell. This thing's a freaking double wide.
I think you should heat your crawl space. You'd have heated floors, and you can heat and cool
Robert
the crawl
Bean
space.
is smiling.
Yeah.
An air to water heat pump. No, I will heat the crawl space.
Mm-hmm.
So the 3 ton is going to end up being right.
Yeah.
But I get into resistance at design. At design, like 11 to 15.
Do you have it set for 3 ton or 2 ton?
It's a 3. I have it set for 3. It doesn't clip it enough to make it worthwhile.
Oh.
I found. So I'll just let the 3 run.
Okay.
Because part of it is we have time of use rates. So it's 4 cents from 9 p.m. to 7 a.m. weekdays, but it's 40 cents from 7 a.m. to 9 p.m. So I want to minimize
Gotcha.
that. Am I getting my Wi-Fi?
You are getting pixelated.
Weird. Okay.
Yep. Yeah, you froze for a minute.
Yeah.
Okay.
Yeah, I'm sure that's what's doing this. Am I back?
It looks like you're back.
Yeah, I switched from one Wi-Fi to another.
I'm about the same.
All right. We have blazing fast internet here, except for when we don't. We got 700 megs a second, but then it loves dropping packets.
Yeah, it's your communicating thermostat and sending all that data over the internet, taking up all your bandwidth.
This is a non-commuting thermostat, tough guy. This is a Train 824, which is not bad either. It shows runtime and whatnot. Tell me about what happened the other day when you had your furnace on, but you were waiting on a part for your heat pump, and then you started the heat pump up.
Yeah, I put the condensing unit in, and it just got too cold to do a really good evacuation, so I just couldn't get to it. And then I was sitting outside. The heat pump was sitting there, so finally I ran like a good chunk of the winter. Bosch, I have a 60,000 BTU furnace, but it's 2-stage, so it goes down to 36,000, I think, BTUs, which
nice.
Which is about what, now, believe it or not, the condo I moved into is pretty decent square footage. It's 100 square feet, but it still had a 60,000 BTU heat loss because, or I mean, 37,000 BTU heat loss. So the furnace is like on low. It's on the low fire. It's sized right for the house. So it's on the thermostat. Obviously, it's got run hours, and I got it staged. And I was also setting back at night. It would see second stage when it was coming out of warm up, but most of the time it was running on first stage. But it was running like 6 to 7 hours a day, and the weather's been in that 20s at night and barely in the 30s during the day. And so really wasn't getting we didn't have many days that we're getting outside of freezing. But a big part of my house is built over my garage. I got a double wide garage, and the living room areas and the kitchen's built over the garage. And so, and the garage obviously is, I do have a heater in it, but I only keep it at 45, 50 degrees just to take the edge off of it, right? So floors in the house were cool, but not miserably cold, but they were it was cool. And I just would put on some slippers or whatever. And so I'm like living like this, and I'm not really uncomfortable, not enough that I'm realizing it. But then I had a day where it broke 55 degrees for one day. So I'm like, oh, I ran out of work, evacuated the heat pump, got it down to 100 microns, cut the charge in, turned the heat pump on. Then it dropped right back down to the same weather again. So then I'm running the heat pump, and my hours go from 6 to 7 hours a day to 16, 17 hours a day. And I'm like, wow, it feels a lot better in here. It feels a lot, all of a sudden the whole house got a lot warmer. So just for fun, I grabbed a thermal imager from the office and I started looking at all the floors and stuff. And there's this giant red streaks going down the middle of over the garage. It was running for so long, it's like pretty much running continuously. Had got the floor like it was a little radiant floor system. So
from the refrigerant lines, or
the supply air runs and stuff had gotten everything started to get warm. And I started tracing it back. Like you could trace every single run in my house.
Yeah.
Because everything now is generating heat. So I got all this. And the floors, you're not talking about a huge temperature, but it's like they're 86, 87 degrees. So
that's cozy. You stand on that in socks. That feels amazing.
Yeah, it does. It feels amazing. So the whole house, like you look around, the whole house is glowing. So I'm like, this is pretty interesting. So then I, just for the fun of it, shut the heat pump back off again and ran on the gas furnace for a little while and took the thermal imager out again. And it's like all that went away because it never ran long enough to warm up those cavities. All those cavities cooled back off again. So my air in the house is getting warm really quickly, but my surfaces aren't warm. And I was like, okay, yeah. And that's what I'm like, yeah, that median radiant temperature, that getting everything warm, getting everything, those long run cycles, getting everything warmed up is what's really making the house like way more comfortable. And then I went back to not setting the house back at night because the heat pump keeps the temperature so consistent in the house that it doesn't wake me up at night because like every time my gas furnace would kick on, it would be enough of a temperature change that it would wake me up. So all of a sudden I'm in bed and I'm sweating because the temperature just went up a half a degree or a degree because you're so sensitive to that.
It doesn't take much when you're in bed, man.
And because the air all of a sudden is getting dry in the house because the hotter air has a lower humidity and
lower relative, same moisture content.
Yeah, but it's lower.
Like, it's got the same number of grains in it.
But when you're breathing that in and exhaling it out, it definitely is.
Relative matters.
Yeah. So it was just interesting seeing how much more comfortable the house was. And it's definitely going to cost me probably another $20 a month to heat my house versus my gas furnace goes. But it's like,
you're going to have to not get coffee a couple days a month.
Yeah. But it's how much you'd pay to be comfortable till you are comfortable. You know, it's one of those things that you got to experience it to appreciate it.
Yeah. That's what I found in doing the house whispering projects. People would talk about payback some, and then the house would be done. And the really consistent feedback was, I can't believe this is the same house.
Mm-hmm.
And so what does it cost you? And I got what I call the Rhett Butler response, which is, frankly, my dear, I don't give a damn. Like, people just don't care. But if you do it, it costs less.
Well, to me, it'd be like taking a cool bath all the time and all of a sudden realizing there's this cool thing called hot water. How much would you pay to have hot water in your tub if all you experienced your whole life was? If you think about it, if baths were
$10 a month plus the tank, basically.
If you started your kid off as a baby and you just gave them a lukewarm bath, and that's all they ever experienced their entire life was a lukewarm bath. They sit in their house and they're lukewarm, and you go, it's comfortable. I'm used to it. You're used to it. And then somebody introduces you to hot water.
Never going back. I want one of those. Hence water heaters as opposed to hot water heaters. They got popular pretty fast.
Yeah.
That was a pretty quick changeover.
You're talking about instant.
Not even, just tanked water
Tankless.
Heaters. Tankless, I'm not that big of a believer in, really, but the tanked water heaters have been around for 100 years now.
Oh, yeah.
Every so often you see somebody who has one of those old Roods still running. They look like they're out of a steampunk show or something like that. Like, they're pretty cool looking. Yeah, water heaters got popular fast because it's a big jump. But another way to look at it was one of my cars had heated seats.
Oh, yeah.
My wife was like, when we were first talking about it, these are stupid. And then I turned them on and her butt is warm before the car is warm. And she's, I don't ever want to be without these again.
Yeah.
We don't have it in either one of our vehicles right now. But once you experience better comfort, like when you didn't know it was possible, it's like, why do you want something else? Mm-hmm. And that's why I want a more variable speed unit here. Because we're over at Moth Manor staying for the week, one of our Airbnbs that has a 5-stage carrier. And upstairs, at least, downstairs, I can hear the air handler. We didn't make the ductwork big enough. We were trying to conserve ceiling height down there in the basement because it's finished now. But upstairs, I can't hear that system run ever. And I just walk in and it's just dead even everywhere. It's just cozy. And I love how that feels. And that house has a mediocre shell. I took it from awful to okay.
Yeah.
I purposely avoided spray foam in that one just to show what could be done with DIY.
The other thing I think is really critical or to indoor air quality and just overall comfort is better filtering. So we spent a few more bucks on putting in a really good media filter below the heat pump. And then I spent a lot of time sealing up every little air leak around it, adding some additional foam gas and making sure there's no air bypassing that filter so that it keeps that interior, that blower and the secondary coil and the heat exchanger and the evaporator coil spotless over time. That's like the cheapest insurance you can get when you consider that fans move in air summer and winter. And if you're using a heat pump and you're on variable speed, you're never really shutting that thing off. It's running 24 hours a week.
When it does shut off, I always leave my fans on.
So do I. Yeah. I kept mine on a really low speed just to filter the air all the time.
Yeah. If you have outdoor air piped into the duct system in whatever configuration, you continue that going.
I think we've got to pay way closer attention to decay test on evacuation to make sure the moisture's out of the system. Because I was thinking about this too. I think we're down 10 degrees this morning, and I'm thinking my evaporator coil is probably a solid 10, 15 degrees below that. My outdoor coil at that point.
Maybe minus 10, something like that.
So if there's any moisture in the system, it's going to fall out in the outdoor unit. And with the heat pump, that's absolutely devastating. So keeping that moisture.
Liquid loves to compress.
Oh, yeah. It's not going to be so much of a problem. It just freezes in the outdoor unit and backs up, and it's going to probably trip on the high pressure switch.
Well, will it end up clogging the refrigerant line?
It'll block the outdoor meter device, and it would back up all the liquid on the inside and cause it to trip on high pressure.
This is part of why we're friends. We usually learn something from the other one if we have a long enough conversation. So it's basically, what do you call it, like a heart blockage?
Yeah, because
a widowmaker.
That's the coldest place, like that system, that liquid's going in there. It's 110, 115 degrees, even that liquid line.
Yeah.
It goes through the outdoor metering device, and it's got to get down to the saturation temperature. So it goes from 110 down to negative 10, right? So there's a 110 degree drop in that liquid temperature, and all that's flash gas. It's flashing off.
The vapor's going to fall right out.
Yeah, and if there's any moisture in it, it's going to fall out right there.
Yeah.
And so it's going to fall out in grains till eventually it just builds up enough to shut that system down. And then until it warms back up again, luckily it's warm liquid there, but once the refrigeration process stops, it'll probably melt it out again. But it'd be a tough problem to track down. But that moisture also causes issues with acidification of the equipment. Eventually it's stripping off acids and stripping off copper and redepositing on the bearings, the compressor, and doing all kinds of...
Is that mainly formicary corrosion?
It leads to formicary corrosion, but it's primarily just electroplating, like where it's just stripping the chemical off, holding the copper in a solvent form, and then it flows through and hits the bearing surfaces and just redeposits. It just gets compressed on there and redeposits on the bearing surfaces.
So it's plating, only it's more of a reverse plating.
It's not like electrochemical plating. It's more like it just plating. Dissolves it in the acid, then redeposits on the bearings.
I think I remember doing an experiment with that with silver back in high school.
Yeah, I'm not surprised you remember back that far.
Only a few years for me.
How long have you been a resident of West Virginia?
4 years now.
4 years, okay.
I finished high school at Hudson, tough guy. That's a good school. But I'm glad the mean radiant that you have been feeling that, because I think that to me is the number one sales pitch for heat pumps, even if it's single stage. Like, I don't love single stage, but if you got a 60K furnace and you have a 3-ton air conditioner and you turn that into a 3-ton heat pump, you actually have something that can run a significant number of hours.
Yeah, that's the issue we don't really grasp. It's the heat loss matching the heat gain that gives you those really long run times, and your heat loss is a variable. It's actually very dynamic and very variable, and it's not a linear relationship. It doesn't seem. You have interior loads, you're cooking, you have cleaning, you have other things going on in there. So your indoor load's constantly varying. Your outdoor load is subject to not only temperature, but solar gain and wind.
I think it's pretty close to linear as opposed to some other things. Although if you have high deltas in a leaky house, it's not linear anymore. But I don't think it's
Yeah,
crazy nonlinear. It's like instead of a to the second power, I think it's like 1.5.
no, I
So
get it, but it's still,
there's
there's people going in and out, doors
yeah,
opening and closing, sun hits the house, some days it doesn't. It's just what I'm
yes,
getting at, a constant variable.
yep,
And so having
fully
the
agree on that.
equipment match that makes a huge difference.
And that's challenging. If you look at the third chapter of my book from 2017, I showed purposely undersizing a heat pump. So taking a
Hmm.
3-ton load house and putting a 2-ton in it, because that bought you another 10 or 15% of the year that you can match. Because if you have a fully variable system at 25%, if it's a
Right,
three
right, right.
ton, it dials down to 9. If it's a 2-ton, it dials down to 6. And it's like that 3 shouldn't matter, but that's actually like a month or two a year.
Hmm.
It doesn't seem like it should be that much, but most climates spend a lot of time in the 50 to 75 range. And I've definitely noticed in my houses with furnaces, on the mild days, they're the most uncomfortable because the
Hmm.
furnace only runs for a couple of minutes. So everything in
Yep.
the house is cold, even though the air temperature is good.
No, that's what you start to experience when you go to that fully. And the other thing is too, is once my furnace got into range, like at 10 degrees, now my furnace is comfortable, right? Because
Yeah,
now it's a
it's
high
matching.
enough load on the house that it's matching the load pretty well. So it actually helps on multiple levels, because it's amazing to me still the phone calls we're getting from people that are very good at this, that still are struggling with control configuration and poor installation and poor application. And so we got a long ways to go with this.
A bunch of things that can make that a lot simpler. Pick a system and run with it
Hmm.
because they're all different. You burned my butt a little bit a couple of years ago, right before AHR, when you wrote about how I set up my Daikin fits wrong because it's the first ones I ever set up. And I didn't realize that if you didn't tell it otherwise, it would shut the heat pump down below 15. You could set it way lower than that, but I
Hmm.
didn't realize that. And we got below 15. And all of a sudden, both of the houses are sliding. I'm like, it'll be okay if I've got the backup and the heat pump, but
Hmm.
one or the other is not enough to do the job. And that's what I planned on with those houses. Whereas, like the Carrier Infinities, I know how to set those things up within an inch of their lives.
Hmm.
And I played with a whole bunch of things and figured out what works and what doesn't. I was
Hmm.
surprised that A, how much energy it saved, and B, how nobody complained. Because I let all my clients know, hey, if this bothers you, just give me a heads up. We can hop on a Zoom call or
Yeah, but I don't think a little bit of cold air matters too much when your floors and everything else is like the mass is still
exactly.
warm.
Yeah, the mass is warm. So even if the air temperature drops a degree, which is what usually happens,
Hmm. You don't really
everything
notice
in the
it. Yeah.
house is warm. So I just set it to whatever the operation mode is. So it shows me what stage it's in. And it's cold enough here that we're hitting a little bit of resistance. But I see it hit defrost and I can't feel the defrost, even though I have it set to cold below
Hmm.
because everything in the house is warm. So yeah, you buy yourself some grace. Although some of it is if you keep your house cold. I was on Blue Sky a little while ago, and a lady's like, man, my upstairs is really cold. I've got it set to 68. And I'm like, yeah, it's because 68 is cold. Turn to 72. Like, it's no wonder you're cold.
Yeah,
Um,
I've done the same sort of thing. I've probably bumped my thermostat up a degree or two. And I got to the point now where I figured out, okay, what am I paying for? I'm paying for comfort. So I'm going to set it where I'm comfortable. Because the other thing you got to realize is that everybody's a little bit different.
mhm.
Depends on what you're wearing, how you dress. Do you wear
How much you're
slippers?
moving?
If you're moving, sit in a chair or you're next to windows or whatever. And I just figured out at some point in my life, I'm like, I'm just going to figure out where I'm comfortable at and set it where I'm comfortable.
100%.
So,
Yeah, that's what I've taught my clients through the years is if the house doesn't feel warm, bump it a degree. If
hmm.
that doesn't feel warm, bump it a degree. And at some point, you'll be like, it's there. And I had one client, she's hilarious. She taught race car driving. She emailed me like a week later. She's like, it's 73.
Yeah.
My house is amazing at 73. I don't know why I haven't done this before.
Yeah. Who was it? Was it Jimmy Carter or Nixon when we had
Sweaters, freezing in
yeah,
the
it's like,
dark, as Reagan
set
gave him
your
a hard
house to
time.
65 degrees
There
mindset.
is. Yeah, my old partner had a client that felt guilty. So they'd never turned to 70. So he gamed their temperature. So it was off by 3 degrees. So when it
Yeah.
said 69, it was actually 72. And all of a sudden they were comfortable, but they didn't feel the guilt because they didn't know. And their energy bills were cut in more than half with a little bit of shell work and a better
Hmm.
system. They didn't know. Sometimes it's the kind of thing you'd have to do. I did it for one client though, and I got caught.
I don't know. Again, we're paying for comfort, but the other thing I saw that was very interesting was like, I'm a big believer in managing our resources the best we can,
Yeah.
but I'm also grounded in reality that the industry is not quite ready for full electrification yet. And that's why I'm really big on the dual fuel thing.
You dragged me over, Jim. So
Well,
I may have dragged you to heat pumps. You dragged me to hybrids.